Hi everybody, my name is Becca, and here's a picture of me and my dog. In this project, we are going to see and work with a ballistic pendulum problem to find out if the velocity of the bullet is the same as what it says on the box. So I'm going to be shooting a 40 grain bullet. Its mass is 0.003 kilograms, and the bullet is supposed to have a velocity of 1,235 feet per second, or 376.4 meters per second. I will see if the factory velocity is true through the use of conservation of energy. I will be doing 2 trials of this experiment. I was going to do 3 before, but one messed up and acted as an elastic collision because the bullet went through the block. When the bullet exits the block, one would not be able to easily complete this experiment because there would be 2 sources of energy leaving the system that you are studying. It would be smart to include some important variables in this experiment. The height in which the block hangs from the ladder, aka the initial height, is 0.3048 meters. The distance between me and the block is 1 meter. And remember that we are trying to solve for the initial velocity of the bullet. So first I will solve for the first trial. A 0.003 kilogram bullet moving east strikes a 0.212 kilogram block on the right and becomes embedded in it. The bullet block system rises 1.04 meters above its initial point. From this, we will find out how fast the bullet was traveling before it collided with the block. So we know the bullet is going to be embedded in the block. So since I found the peak height, I needed to calculate the final speed of the bullet after the collision. Once I had that, I could find the initial speed of the bullet. So let's focus on conservation of energy. After the collision, the bullet block system will have a kinetic energy also known as Ke, and as it rises up, the energy will be converted into potential energy, also known as Pe. So write down Ke equals Pe. This can be rewrote as 1 half mv final squared is equal to mgh. Here I can cancel out the mass because it isn't important. So I have g and I have h. G is 9.8 meters per second or meters per second squared, and the height is 1.04 meters. So 9.8 meters per second squared times 1.04 meters equals 10.19 meters per second squared. So I have 1 half the v final squared is equal to 10.19 meters per second squared. To get rid of the 1 half, I multiplied both sides by 2. Half times 2 is 1, and 10 times 1.9 meters per second squared times 2 is 20.38 meters per second squared. Then I took the square root of both sides, so the square root of 20.38 meters per second squared is 4.51 meters per second. So this gives us a final velocity of 4.51 meters per second. So that is the final speed of the bullet block system after this collision. So now that I found final velocity, initial velocity can be found. So now I need to deal with momentum. During a collision, momentum is conserved. I use the formula m1v1, which is the momentum of the bullet before the collision, plus m2v2, which is the momentum of the block before the collision. And that should equal the momentum of the block system, which the mass of that system is the sum of the mass of the bullet and the mass of the block. And this system will move together at the same final speed. So m1 is the mass of the bullet, which is 0.003 kilograms. Our goal is to calculate v1, which is basically the initial speed of the bullet. m2 v2 will be 0 because the velocity of the block at the start is 0 meters per second. because the block is at rest before the bullet strikes it. The total mass is going to be 0.003 kilograms plus the mass of the block, which is 0.212 kilograms times the final velocity, which now I know is 4.51 meters per second. So 0.003 kilograms plus 0.212 kilograms equals 0.215 kilograms. Then you multiply that with the final velocity, and which is 4.514 meters per second. So that's when you get the final momentum. Everything on that right side, it is 0.971 kilograms times meters per second, and that is equal to 0.003 kilograms times V1. I then divided both sides by 0.003 kilograms to get the bullet's initial velocity. So the initial velocity of the bullet is 323.5 meters per second, which is 52.928 meters per second slower than the velocity advertised by the factory on these bullets. For the second trial, this can be calculated in the same way, but the height that the bullet block rises will be different. And that height is 1.016 meters. I provided my math here so that you can see it. The final speed of the bullet block system after the collision in trial 2 is 4.46 meters per second. And then the initial velocity of the bullet in the second trial is 319.6 meters per second, which is 56.798 meters per second slower than the factory statement. Next, I am going to show you my experiment videos so that you can actually see how I calculated this. I had a measuring stick on right next to the bullet block system. So I'm going to shoot my bullet into the block, and well, you can see for yourself. In case you were wondering, I looked at the highest peak point of the block and compared it to the measuring stick to get my measurement. And this is trial 2. I would just like to say thank you for watching, and I hope you enjoyed my physics project. And this is a picture of me holding the .22 cartridge that I shot today on the left, and then on the right of it is it squashed when it was fired. So maybe that will give you a understanding of what it looks like before and afterwards.